Hey guys, this week in the science questions we are looking at a research summary type question. And so this is one of the question types in the ACT that's characterized by having several different experiments. So you can see here we've got experiment 1 and we've got experiment 2. There are 3 passages in the ACT that are research summary questions, and they're identified by having those experiments and also having 6 questions per passage. So that's a total of 18 points we can get, 18 questions we have in this type of question. So we'll do these last because that way we maximize our points in the earlier part of this. The best strategy for reading and answering these questions in research summaries are to read through the questions first and just make sure that you may not have to read the entire experiment number 2 yet. So we'll look at this and let's see. Question number 1, we have experiment number 1, so we know we have to read experiment 1. Question number 2, there's nothing about either of the experiments, so we're okay there. Question number 3, we've got both experiments, so we should probably look at them. Question number 4 is only experiment 1, and question number 5, we have doesn't say anything about either of them. So we can look at experiment number 1, and actually looking at experiment number 2, there's not as much information there, so that's not a big deal. So let's go ahead and look through. So it's describing carbon monoxide gas that's similar to carbon dioxide, but there's only one oxygen there. So we have carbon monoxide gas, and it's toxic in the air at concentrations above 0.1% by volume. Cars are a major source of atmospheric CO in urban areas. Higher levels are observed during colder weather. So colder weather has more CO. Students propose that cars emit more CO at colder air temperatures than at warmer air temperatures during the first 15 minutes after they're started. So they're going to test this hypothesis. They tested it in experiment number 1. A hose was connected to the tailpipe of the car. They put the exhaust into a plastic bag. A sample, 1 milliliter sample, was taken from the bag with a syringe, injected into a gas chromatograph. All right, we got a gas chromatograph which separates the mixture of gases into its individual components. Comparisons of the exhausts with mixtures of known CO concentrations were made. So that's how they figured out how much there was. They knew concentrations, and that was a control, and they determined that percent by volume in the exhaust. So they had something to compare it to when they measured it. They collected at 2-minute intervals, and samples from each of 4 cars were tested at external temperature of -9 degrees Celsius. So at -9, and that's table 1. So we can see this here, and we've got several models. We got a model in 1978, 2 models in 1978, and 2 models in 1996. So we've got 2 different cars here, and these 2 different cars, or 4 different cars, are putting out this CO. And so what the first thing we notice is that older cars put out a lot more carbon monoxide than newer cars. We've got 1.2 versus a 3.5. That's a pretty high difference. And these got all the way down to 0.4 and 1.8. And this one was all the way up at 7 and 10 here. So those are some pretty high values. We should look at those a little bit later. While we're at it, let's just look at experiment number 2, just so we can see what else was going on. So they did the same experiment, but they did it at 20 degrees. And at 20 degrees, those cars did something different. It's kind of interesting. They're lower. Instead of having 3.5 up here, we're at 2. And so it does look like they got a little bit lower at the warmer temperatures. So it's warmer, and so it's less. So warm equals less. They were right. That was their hypothesis. Warm is less, and cold is more. So let's look at number 1. Do the results from experiment 1 support the hypothesis that at a given temperature and time the exhaust of newer cars contains lower percents of CO than the exhaust of older cars? So we're looking for newer cars and older cars, and hey, yeah, we did see that. So newer cars did have lower exhaust, so we can go ahead and get rid of the 2 that say no, because we do support that hypothesis. And so the answer choices we have now are the highest percent of CO was in the exhaust of the 1996 Model Y. Well, that's not what we saw. In fact, the highest percent of the exhaust was in the 1978 Model Y, not the 1996. So we know that F is not correct, and G has to be the correct answer. Look at number 2. A student, when using the gas chromatograph, was concerned that CO2 in the exhaust sample might be interfering with the detection of CO. So they're worried about that, and so what we might do in this case, we have to make a control. We have to figure out what CO2 does when you've got CO in there. And so what you want to do is you want to make a control. And the best way to make a control is not collecting exhaust from additional cars, not injecting a sample of air into the gas chromatograph, but it is testing a sample with known amounts. That's what a control is, known amounts. So D is our best answer for number 2. Look at number 3. Based on the results of the experiments and the information in the table below, cars in which of the following cities would most likely contribute the greatest amount of CO into the atmosphere in January? So January, we're thinking cold, right? And so assume the types, numbers, and ages of cars are approximately equal. Well, we've got 4 cities. We've got Minneapolis, Pittsburgh, Seattle, San Diego, and the temperatures in January. And the coldest one is Minneapolis at 11.2. And so we know that cold equals more CO. And so the colder it is, the more carbon monoxide they're going to make. So that is F, Minneapolis. In number 4, Experiment 1, we're back to Experiment 1. Which of the following factors varied? What did they change? That's what varied means, change. So did they change the method of sample collection? Did they change the volume of exhaust? Did they change the year that the cars were made? Or did they change the temperature the engine was started? Well, they only started the engine once. They did not change their methods. They did not change their volume. They did have different years. So they had 1978 and 1996 years. So C is our answer. Number 5, many states require annual testing of cars to determine their levels of their CO emissions. Based on the experiments, in order to determine the maximum percent of CO found in a car's exhaust, during which of the following times after starting a car would it be best to sample the exhaust? So we're looking for the maximum and what time those maximums are. So let's go back to our data and we'll actually just look at that. So where's our maximum for Model X in 1978? 4.5 is our maximum. Maximum here is 10. Our maximum here is 1.5. Our maximum here is 3. Those are all between 5 and 7 minutes. We can see that 5 and 7 minutes is one of our answer choices. So let's go ahead and kind of maybe star that one, and then let's look down here. So let's look for their maximums in warmer weather. Well, this one is 3.4. That's at 5 minutes. Here's one at 7 minutes. Here's one at 5 minutes, and here's the one at 5 minutes. So between 5 and 7 minutes is probably our best answer. And that is how you answer a research summary question.